What an honor to be here with you. And if this morning isn't a reminder what this is all about, I don't know how to do it. It's about people, right? I mean, I have a science background, a science degree, but it is all about the people in the end. The sustainability is continuing to come together. Every single disaster, 26 years in the Weather Service. I've seen Katrina, I've seen oil spills, Deepwater Horizon. I've worked so many events. Every single one of them becomes about people. And we're in the disaster zones ourselves. I remember going back to Katrina, I remember hurricanes where my family didn't have power for a week, and I have a small little generator that I started up. And I was in contact with the family, and I said, everybody okay? This is while giving briefings. This is while doing what we have to do with hurricanes. Yeah, everything's fine. The generator's running. Day one. Day two, how's it going? Everything's fine. We're okay. The generator's running the small refrigerator. We have cold water, and we have a radio. Everything's fine. Day two. Day three, generator's running. Wait a minute now. Generator's running after 3 days. I don't know. She goes, I don't know. I haven't touched it. It just keeps running. I said, I'm going to be a commercial for the best generator ever made. I don't know. Maybe power company. We need to consider this little generator. After 5 days, this generator ran. For my wife and my 3 kids, they had a fan in the refrigerator. I couldn't believe it. So it was weeks later. I was standing outside talking to some neighbors, and I told them the story about how this amazing generator kept going. They said, "Oh yeah, in the middle of the night, we kept sneaking to your house to fill it up with gas." Every disaster I've ever seen, Katrina, I was deployed to Samoa after the big tsunami. Every one of them, we become stronger afterwards because you have conferences and discussions like this. Does that make sense? And that's how you become stronger. So I wanted to really advocate for that. I wanted to give a perspective real quick about some of the science. Our agency, the National Hurricane Center, we cover from Europe, Africa. We had 18 storms in the Atlantic, very strong, and 17 and 19 very powerful. But even 2018, we had Florence and Michael, just constantly these rapid intensification storms that are just quick notice. They're fast and it's quick, but we don't always have these. And I did want to say, remember Lorenzo from last season, way out in the Atlantic? And it's something that I'm really trying to let people know. There's a saying called, it's far out, we don't have to worry about it. Do you know it was the second leading cause of fatalities from the 2019 season? I bet you wouldn't think of that because it's way out there, right? It hit that tugboat, so you lost the sailors on that, and it killed 8 people in the United States from rip currents, including a NOAA employee. Interesting enough. So it's about those impacts. It's not about these tracks and the intensities. It's about the impacts from each one of these. And also the Pacific. We also have to issue watches, warnings, and also cover the forecast for the Pacific. And it was busy as well for us. I wanted to talk about the statistics because it's important when it talks about when you get into the resiliency and start talking about sustainability. We're getting better at the forecast track. I mean, if you look at this graph, it's a little bit of science. The lower the line, the better we are at the track. We're getting good at the track. Look at the 2010s. I mean, the track forecast is getting so much better. It's a scientific breakthrough when it comes to this. So why does it matter on the ground? Well, we have a tendency, so many models, we have models available on our phones. You see the models, you compare the models. I just want to urge everyone, be careful. Because if you look at history, the official Hurricane Center forecast has beat the models every single time. So we have situations where we're looking at different models. We're looking at this. If you look at history, 2017, 2018, 2019, the graph on the right is our forecast on the top versus all the models. You got an official forecast. We're working so hard to make sure that you have the information that you need. So keep that in mind when we go through these systems. Why does that matter? And I'll show you an example over the Bahamas here in a second. That round circle in blue was our forecast cone in 1990. The red, that's our forecast cone in 2018. That's why it matters. Because if you're an island, 100 miles makes a difference. Does that make sense? It really makes a difference. So I commit to you from the Hurricane Center, we're going to do everything we can to continue to improve the forecast because that helps you, right? Okay? So be careful with some of that. So, and here's another example. You may have your favorite model, but it depends on the hurricane, depends on the day, it depends on the season. They all have their good days and they have their bad days. So be careful with that kind of stuff. We have that information for you. The spaghetti plots, Do they really look like spaghetti? Maybe, sometimes. But be careful of that. But you're going to have citizens that you serve that are going to be looking at the internet trying to find that one line. If they're a positive person, they may take the one line that doesn't hit the Bahamas and they won't take action. But if they're a negative person, they're going to find that one line that hits the Bahamas and they're going to be panicked. That's what we have to deal with. It's a new society with so much information that goes out. So remember who we're serving. I added up 175 years of experience at the Hurricane Center. So it's interesting. So when you get that forecast, that's what we're looking at. Track errors continue to go down. We got some impacts there. We struggle. One thing we do at the Hurricane Center, we will let you know what we're doing well, and we will let you know where we struggle. Okay? And we did well with the average forecast errors for the whole season until the very end. Look at Pablo and Sebastian. They were so far north storms, right? The model struggled and we struggled. We had some of our worst errors in years trying to track those two hurricanes. So we're going to share with you where we struggle as well. It's interesting. Watch this. This is why it matters. That's your 5-day track error. 4, 3, 2, 1. That's how we do it now. So think about it, as you get closer, we really narrow in the focus of where this forecast is going to be. This is over you, over the Bahamas. 1990, that's what we would have given you 3 days prior. That's today. Okay, so you have to understand the forecast is getting more accurate, but we're still struggling with the intensity part. Look at the intensity. We still struggle with intensity. We don't fully understand what the ocean's contributing. We don't fully understand. We may be looking at shear, which is inhibitor this big, but maybe it's the shear this big that's contributing to the intensity. We have a lot to learn when it comes to the intensity. So we're going to do a great job at the track. We still struggle with that intensity part. For the Bahamas, the intensity of Dorian, we've seen some of the presentations already, but I wanted to share I don't have to go through all this in the interest of time because there's some things I really want to cover on the social science. You can see just the evolution. You have a small wave, nothing there. You have the residents looking at that, and it gets stronger with time, becomes a tropical storm. You can see the whole timeline, but the rapid intensification is the part that has really been fascinating that we've been able to watch in recent years. Again, I don't have to go through all this. You can see it there because I really want to get to it. In the U.S., we also had landfall as a Cat 1, and Canada was impacted as well. Major power outages. So Dorian had a long, and I don't know how the power companies, you guys talk to each other, just an incredible impact to Canada as well. So it was a long period of time dealing with Dorian. This is something very important. From a science perspective, your forecast will be better for stronger storms. When they're developing, when they first start, during the genesis phase is what we call it, they're very difficult to forecast. Very, very difficult to forecast. The stronger the storm, the better we do with the actual forecast, which is kind of interesting. So the small storms, those weak ones, they behave a little funny. Okay, so it's just something to keep in mind as we go forward. There was a period of time, this is the genesis phase of Dorian. We had aircraft going in there. You think when we send the hurricane hunters at the Hurricane Center, we actually draw up the missions for the hurricane hunters. We talk about where they drop the drop zones. We plot out their missions, everything from the Hurricane Center. This was the most critical time for us. It wasn't when it's already developed. Remember, we do better when it's that. Here, there were 3 centers. There were 3 centers. We were tracking 3 different centers in Dorian. Why does that matter? Big time. Watch the 3 scenarios that could have happened with Dorian. One scenario, which all the models picked up on at the beginning, one scenario was to the very left of the cone, hitting land, Hispaniola, dissipating, and maybe not even reemerging as much. Isn't that interesting? That's scenario 1. Okay, but it dissipated, maybe some rain. Scenario 2, still some interaction with land. This was closer to the official forecast. Some weakening, but then a good chance to strengthen. 3 different centers, remember? That's why that genesis phase is so powerful. The 3rd scenario is what actually happened. There was a day we had the hurricane hunters in the actual genesis phase of Dorian. The center jumped to the north. We then knew which center was going to happen. We know this scenario was going to happen as well. That's when we updated the forecast. Once that jump occurred, more warm water, more time to be over the more warm water, slower movement, which means, remember the high pressure? The left, by the way, the scenario 1 and 2, you probably wouldn't have a stall over the Bahamas. Think about how sensitive that forecast is. On that right track, you got away from the steering currents, and that's when you had the stall over the Bahamas. Isn't that interesting? So all those scenarios were possible during that initial phase. That's tough forecasting, right? So that's kind of what happened in that third phase. We look at data. I don't have the data yet for Dorian. We're still collecting it. We have radar data on the aircraft with the U.S. Air Force, the NOAA hurricane hunters, and anything we have on the ground. We're comparing all this radar data during these phases. We have tons of data coming in. And the official forecast, if you look at the data, those are all the forecasts for Dorian. Not bad on the track. It was the intensity that was so difficult because the models were taking it over Hispaniola to tear it up, and that made it very difficult when you had that jump. So I'll say the models had 100-knot error at 5 days out. Why? Because all the models had it over Hispaniola. The track was good. We still struggle over the intensity. At the time, 2.6 million people evacuated. There were warnings for this, by the way, similar track to Dorian. That's why I show it. Very similar track to Dorian, Hurricane Floyd. There were warnings up for South Florida, evacuations, lots of evacuations. This was Dorian. Because of the confidence in the forecast, 3 million people did not have to evacuate in the U.S. for Dorian. That's huge. And we have places to evacuate. If you're on an island, it's tougher. You don't have places to go. Right? All you got to do is seek high land, and that's not easy to do. So it's a bigger challenge, and we totally recognize that with time. That's the difference between the two cones from 1999 and 2019. So we are getting there. We have some new tools for you to use, and I'm going to announce a brand new one. This is the first time that we've announced it. I'll announce that here in a second. This time of arrival graphics for you to use. It's the arrival of tropical storm force winds. So it's very important because once you get that in the power companies and others, this represents when it's too dangerous to be outside. Anybody, the lineman, if you got plywood, tropical storm force winds mean it's too dangerous to be outside. Even emergency services could be impacted. So we try to get this information out for people to see. This is the social science part of this. This is from 2012 back to 1963. Water, 90% of fatalities. We have the evidence, we have everything. Water is the result of 90% of fatalities in tropical systems. It's the water, sustainability, the dangers of water. That's what really we're looking at. In the U.S. is an interesting study. Over half of those in the United States were in automobiles. So out of that 3-minute warning, that's good. So there's only 40 more slides, so I'm going to do it. So automobiles. This is an important topic to what we've heard this morning. This is very important. People tend to say this all the time. Well, the storm has passed. I'm safe now, and that is not true. If you look at indirect fatalities, we're losing more people in the long term than we are directly from the hurricane in some situations. Okay, the number one cause of fatalities after the hurricane makes landfall, cardiac arrest. If you go back in time, it's cardiac arrest. It's health issues. It's getting help. And this is brand new information we put together this year. It's also, you start looking at who's most vulnerable. You're 8 times more likely to be a victim over 60 as under 21. Right? It's the elderly. They've got to really take care of the most vulnerable patients, the most vulnerable here. We have the data. And it's cardiovascular. You can see it there, and I'm going to rush to completion. And there's, by the way, this is an interesting stat. We actually lose people during the evacuation. Even the evacuation of stuff, evacuating a hospital. Yeah, you're saving lives, but it's risky business as well. Okay, it's interesting. So timelines, I encourage everybody to be careful with this. Some you'll have lots of time coming off the African coast. You have 10 days to get ready. Okay, you work your plans. Maybe your 5-day plan feels comfortable, right? Be careful of these. You may have 3-day notice. Please work your plans. Take your plan, cut it in half, rework it as if you have half the amount of time. I really urge everybody to be careful with that. I want to say this also real quick. There's been 4 Category 5s. 4 Category 5s that have hit the United States in history that we have recorded. Interesting enough, this is the continental U.S. in this particular study. Every one of them was a tropical storm 3 days prior. Rapid intensification. You got to be ready. You got to ramp up those plans because history says what we have to do. Okay, in the interest of time, I'm going to wrap up towards the end. You can see the social media is so important, and be careful because there's lots of different types of social media. My kids tell me Facebook's for old people. Oh, so those students were like, TikTok, I have no idea what that stuff is. That's where the young people are getting information. Consider all the variability of even the social media. My kids are using Instagram. They don't use Facebook just because I use it. That's bad. Where are we going in the future? And then I'll have my big announcement at the end because I think it is important. I wanted to do it here. We're going to keep getting better with the forecast. However, everybody wants a day 6 and 7 forecast. You know we only go 5 days out. Everybody wants a 6 and 7 day. We're working so hard to give you that. The problem is this. That's Florence. The white line is our forecast for Florence. The blue is the 6 and 7 day models. When you see that, you're going to have residents with a lot of relief, and they shouldn't be relieved. We don't know how to depict that yet, if that makes sense. There's so much variability out. We're also going to be doing this, where the storms, remember what's the leading cause of fatalities? It's the water. Storm surge is the number one. It was a 10-year project. We just finished the storm surge watch and warnings. Remember the comment this morning, it's not just about the winds, it's about those impacts. We just finished storm surge watch and warnings in the United States with inundation mapping. We've only been doing it 3 years. You have to have bathymetry, you have to have elevation. There's a lot of modeling that goes into that. Okay, Puerto Rico, we got it done for the 2019 season. Southern California for this season, and we're moving to put it out to 72 hours. But here's the bottom part. This is the first place that I've told anybody about this brand new project, and I wanted to do it here because it was special to do that. We're getting the data. We had a pilot project in the Dominican Republic and Haiti, 2018, 2019. Proofs of concept that we can even do it. Right, this is all brand new. All brand new. Belize and Yucatan, 2021. And then red here I wanted to announce today for the Bahamas. We're going to start the project in 21. We hope to be done in 23. Cross my fingers, it's a lot. We'll have storm surge capability, inundation, and the ability to issue watch and warnings for the Bahamas. So, the vision is to go all the way across the RA4, the entire region really is important, because if that's the leading cause of fatalities, we need to be able to model it accurately and get you that information. So that's all I have. I could go on, but there was about 60 slides I did in 15 minutes. You got to be proud of that. So anyway, thank you very much.